So today we're going over section 5.1. There's a lot of notes on this, but a lot of it we've seen before because it's transformations. We're just doing it with quadratics now instead of absolute value like we did before. So our learning intentions. The student will be able to transform quadratic functions using vertical and horizontal shifts, reflections across the x-axis and the y-axis, horizontal and vertical stretches and compressions. And the student will also be able to describe the effects of changes to a quadratic function by using the coefficients of h, k, and a of the function f of x equals a times x minus h squared plus k. So hopefully you should recognize that on this, the only difference between this and absolute value is now we have parentheses, with the parentheses being squared. And so a lot of the stuff is going to be really similar to what we did before. And hopefully when we finish this, the student will be able to do the above by going through the notes, doing examples, and completing page 320, numbers 17 to 41, the odds. So hopefully we'll accomplish this as we go through the lesson. So a quadratic function is a function that can be written in the form of f of x equals a times x minus h squared plus k, where a is not equal to 0. It can be anything but 0. The parent function, we've talked about parent functions with absolute value. Again, that's the simplest quadratic we can have, and that would be if we had f of x equals x squared. So let's go ahead and graph what that would look like. If we, again, we can make a chart. So if I was to make a chart, and let's start at 0. If I plug in 0, 0 squared would be 0. 1 squared would be 1. 2 squared would be 4. And going the other way, negative 1 squared would also be 1. And negative 2 squared would be 4. And so if we were to graph this, at negative 2 we'd be at 4. At 1, negative 1 would be at 1. At 0 we're at 0. At 1 we're at 1. And at 2 we're at 4. And so our graph would look something to this effect. Okay? And the graph of a quadratic is a parabola. So with the absolute value, you know, we had the v or the upside down v. Well, now we have a parabola where they're not straight lines, it's curved, and its slope is not staying the same, so we don't have the slope like we had at the absolute value. So that would be the graph of the parent function. So before we go through transformations, I want to look at, they're going to ask you to do some graphs of just quadratics. So an example would be, they might give you the quadratic function f of x equals x squared minus 6x plus 8. So one of the things they're going to ask you to do is to graph these. And when you have something like this, we're just going to have to make a chart. And so let's make a chart, and I'm going to start at 0. And we're going to have to decide from here by plugging in which way it's going to go. So I plug in 0. 0 squared is 0. 6 times 0 is 0. So we get 0 minus 0 plus 8. So let's go ahead and write that out. We'd have 0 minus 0 plus 8. So when we plug in 0, we're going to get out 8. If we plug in 1, we get 1 squared, which is 1. Negative 6 times 1, which is a negative 6, plus 8. So we get 1 minus 6 is a negative 5, plus 8 is 3. And if I plug in 2, I get 2 squared, which is 4. Minus 6 times 4, which would be a minus, or 6 times 2, which would be a minus 12, plus 8. And so we get 4 minus 12 is a negative 8, plus 8 is 0. If we plug in 3, we get 9 minus 6 times 8, or 6 times 3, which is 18, plus 8. So we get 9 minus 18 is a negative 9, plus 8 is negative 1. And when we plug in 4, 4 would be 16. 6 times 4 would be a negative 24, plus 8. So we get 16 minus 24 is negative 8, plus 8 is 0. So what we found is we found this turning point, and that's halfway between there, so that's our vertex. So let's go a couple more. If I plug 5 in, I should get 3 out, so let's check that. 5 squared is 25. Negative 6 times 5 is a negative 30, plus 8. And so we get 25 minus 30 is a negative 5 plus 8, which is 3. And so now we know that 6 is also going to give us 8. And so we can graph that now. At 0, we're at 8. At 1, we're at 3. At 2, we're at 0. At 3, we're at negative 1. At 4, we're at 0. 5, we're at 3. And 6, we are at negative 8. And so we get, again, this parabola look for our graph. So when they give you a function written in this form, where it's just written out, we're going to have to make a chart, plug in the numbers, and get our graph. And so you're just going to have to pick numbers, try a starting point, and work from there until you find the vertex, and then you'll know what the other numbers are. One thing you'll find, if the x squared is positive, this graph is going to go up. So when I picked this 6 or 0 and I got 8 and I knew it went down, now I knew I was on the downward trend and I'd have to come back up again. If that x squared is a negative sign in front, it's going to open down. And so if I would have seen that this was going down, I would have wanted to go the other way to find out what the number's going up or to find my vertex. So the graph's always going to be a parabola. And now we're going to look at the translations of quadratic functions, which is identical to what we did with absolute value, except we're taking quadratic, so we have parentheses instead of the absolute value bars. So, a horizontal shift of h units and vertical shift of k units. Remember, the h sends us left and right, and the k sends us up and down. And if we're going back to here, remember the h is inside, just like with absolute value, inside is horizontal, outside is vertical. So if we just take a horizontal shift of 8 units, remember it's the inverse and opposite, f of x equals x squared. So with the horizontal shift, we're going to do the opposite of what it says. So if it said 2 left, we would write this as x plus 2. And if it said 3 right, we would write that as x minus 3. Again, squared and squared. Outside, remember, is vertical, so it goes outside. Now we just have x squared here. That just means that our h is 0. That would be the same thing. So anytime it just says x squared, know that your h is 0. So the k goes up. So if it said up 3, we would write x squared plus 3. And if it said down 5, we would write x squared minus 5. So remember, h, if it's less than 0, it moves it left. Again, that's before we take the opposite of it to plug it in here. So if it's a negative 3, we go back to the 2 to the left, that would be x plus 2. And h is greater than 0, so if h is 3, which is 3 to the right, we plug 3 in and we get x minus 3. Same thing with vertical, less than 0 moves it down, greater than 0 moves it up. And so this would give us we can do shifts of both. So let's say they ask us to let's go shifts right 7 and shifts up 5. So our equation, if we go back to here, would be x opposite right 7 is minus, so minus 7 squared, and then up 5 would be plus 5, and you'd have your function. So again, exactly like absolute value. The same thing happens with reflections, stretches, and compressions of quadratic functions. So reflections, remember, horizontal reflection, horizontal is inside. So the negative sign goes inside the parentheses. It just affects the x. A vertical reflection is outside. So it's outside the parentheses, outside the x squared. So here, when you write it this way, you would get negative x squared. So remember, the squared affects both the negative sign and the x, so it ends up being exactly what it was. And if you think about it, if I reflect this horizontally, this side just goes to here, and this side goes to there, so you can't tell the difference. The same, but when I do it this way, it's going to take it and flip it down. Because remember, if A is negative, it's going to go down. So that, again, same as absolute value. Remember, so this is what I was talking about. The function is its own reflection across the y-axis. So if you reflect it across the y-axis, it's going to look the same. But with this one, it's flipped across the x-axis, which sends it down. So this graph, if it was this way, then would go like this. All right? And then we have the stretches and compressions. Again, hopefully this is real familiar from the absolute value. If it's horizontal, stretch or compression, remember it's the inverse, and because it's multiplied, it's the reciprocal. So if it's horizontal, it's inside, so remember that's 1 over b. So if we said, let's go horizontal stretch of 2, so b is 2, so that would be written 1/2 x squared. If we did a compression, let's do a compression of 1/2, or let's do a compression of 1/2. Remember, it's the reciprocal or multiplicative inverse of what it was, so we flip that over, and so that would be 2x squared. But remember, if it's horizontal, it goes inside before it's squared. When it's vertical, it stays outside of the function, and so it's ax squared. For both, remember, if b is greater than 1, it's a stretch away from the y-axis, and if a is greater than 1, it's a stretch away from the x-axis, so vertically. If it's between 0 and 1, the absolute value, or less than 1 absolute value, then it is a compression towards the y-axis or a compression towards the x-axis. And we'll do some examples of these as we finish up. But again, it's the exact same rules we had with absolute value. The only change we're making, remember, if I did absolute value, I could have all of these transformations. So now the only difference between this is we have parentheses now, and it's squared for quadratic. But the rules, everything you see is set up the same way. All the rules are the same. So hopefully this is going to be easy to apply to quadratics if we were good with the absolute value functions. The vertex of a parabola, remember, is the turning point. And that's the highest or lowest point of a parabola. And if you remember, the vertex, just like before, the vertex is hk of the parabola. So when we look at the form, when it's in vertex form, we can find that. And so what we're saying here is the vertex there is going to be, if it opens up, it's going to be the lowest point. And if it opens down, the vertex will be the highest point. And that will be the k value of each of these. Because remember, our k value is our y value. So if this was 2, 3, then the lowest value is 3. And if this was, let's say, negative 3, 7, then our highest point would be at y equals 7. So, vertex form, again, what we talked about, really similar to the absolute value. The vertex is hk, which we just went over. So, A indicates a reflection, compression, or stretch vertically. B indicates a reflection, compression, or stretch horizontally. H indicates a horizontal translation, or slide or shift. And K indicates a vertical translation, slide or shift. So, kind of a summary again, same as what we had before. Remember, if it is inside the parentheses, then you have a horizontal transformation, and it's always the inverse of what is written. So if it says times 3, it's really our B is 1/3. If it says minus 5, then it's the opposite of that, plus 5 for our H. If it's outside the parentheses squared, then you have a vertical transformation. Remember, that's what it says it is. And then for both of them, if it's multiplied, it's multiplication, it's a stretch or compression. And if it's add or subtract, it's a translation, slide, or shift. All those words you could use. So I want to look at some examples of what you're going to have to do on the assignment. I want to use this graph we had up here before. So they're going to ask you to describe and graph. So an example that we have is x minus 2 squared minus 1. Let's say this is f of x. And they're going to ask you to describe the transformation and to graph it. So a couple things. Let's go through the transformations first. One transformation is it's minus 2, so it's inside, so it's horizontal, and it's the inverse of what it says. The additive inverse of minus 2 is plus 2, so that would be shifts to right. Okay, and again you could put translates right to, or slides right to, or shifts right to. And then the minus 1 is outside, so that's vertical. And so that shifts. And it's negative 1, so down 1. Okay, so we've covered the translations. Now they're going to ask you to graph that. And there's a couple ways you can do this. If we go back, I'm going to put the parent function on here at negative 2, 4, negative 1, 1, 0, 0, 1. So this was our parent function. Well, we already know that this one is going to shift to the right 2 and down 1. So it's going to start here. Now everything else has stayed the same, so our spacing stays the same. So one thing we can do is we can make a chart. And you always start at the vertex if you do that, 2, negative 1. And then you would plug in numbers on either side, but no, it's going to be symmetrical. So when I plug in 1, 1 minus 2 is a negative 1, and a negative 1 squared is 1, minus 1 is 0. So that means 1 is 0, and 3 is 0. And if I plug in 0, 0 minus 2 is a negative 2. Negative 2 squared is 4. 4 minus 1 is 3. So that's 3, which means 4 is 3. So I could graph that. I'm at here, I'm at 1, I'm at 0, 0, and at 0, I'm at 3, and here I'm going to be at 3. And so I would get this graph, and so it's going to be the exact same width, everything there. So again, you start with the vertex. So our vertex was 2, negative 1. We start our chart there, and then we just plug in numbers on either side, but know that it's going to be the same distance away on either side. So you can plug these in if you want, but you know that they're going to have the same value as what you got out there. Another way to do it. Some people like this, some people don't. So let me show you what you can do. We know this. To find these output numbers, instead of plugging them in and getting them out, if you go to your A value, in this case A is 1. All you have to do, if we go back to our parent function, is you're always going to use these values. Our parent function goes up 1 and then up 4 from the vertex. All you have to do is multiply A times 1 and 4, and that will tell you where your points will be. So 1 times 1 is 1, so that means it's going to go up 1, so 0, which is what I had. 1 times 4 is 4, so it's going to go up 4 from the vertex, and so that's going to be at 3, which is what we had, and that has to go the same way. That will always work. You just multiply A times 1 and 4, and you can fill out the chart without having to plug it into the formula, which saves some time as you get to more complicated formulas. All right, so that would be one example. Let's do another one. Have f of x equals x squared minus 5. So here's where people get confused on this one. Remember, if it's outside the parentheses, it is a translation up or down. So it's vertical. If it's inside, it's horizontal. Well, because there's no parentheses, sometimes people get confused. This is just x minus 0 minus 5. So our vertex is located at 0, negative 5. If it helps you to write that, then by all means do. But we know our vertex is going to be located right there. So our transformation, in this case, is going to be that it shifts down 5. Now we have to graph this. We already have the vertex. So again, you could, starting at 0, negative 5, you could plug in the numbers and work that out. Doesn't take a long time because you really only need to plug in 2, but because you know the other 2. But again, if we can go back to our parent function and use this 1, 4, our A in this case is 1. So 1 times 1 is 1, so that means I would go up 1. And so that would be negative 4. And 1 times 4 is 4, so I would go up 4 from negative 5 and be a negative 1. And these would be the same. So at negative 2, we're at negative 1. At negative 1, we're at negative 4. And so we get our graph. And that's all you have to do on those. Let's take a look at a couple more complicated ones. So f of x equals x plus 3 squared plus 2. So we know our vertex already. Opposite what it says. Negative 3, 2. Shifts, negative 3, so left 3. And positive 2 is vertical, so shifts up 2. So we've got our transformations. And let me show you how we can do this graph now. Again, we know that our parent function, all we're using is those numbers 1, 4. So we are at negative 3, positive 2. And 1 times 1 is 1, so I go over 1, up 1, both sides. And over 2, up 4, both sides. And we have the graph. Now, you're welcome to make the charts. You're welcome to plug in numbers. You can just get away without doing that if you can always remember the parent function from the vertex goes up 1 and up 4. What if we run into something that's a little bit different? Let's do as complicated as you're going to see on this. What if I did negative 4 x minus 2 squared plus 3? So we have to describe the transformations. So we have a lot of transformations in this. Negative sign is outside, so it's vertical. So reflects vertically. The 4 is multiplied, so it's outside, so it stretches because it's greater than 1. Because remember, it's absolute value, so the absolute value of negative 4 is 4. So that's a vertical stretch of 4. Minus 2 is inside, so it's horizontal, and it's the inverse of what it says. So shifts 2 right, or right 2. And the plus 3 shifts down 3. Now let's go to the graph of this. And we're going to remember this 1, 4 for our parent function. 0, 0, 1, 1, 2, 4. So this one, our vertex, we know is at 2, 3. So 2, 3. Now, again, you can plug in numbers and make this chart. But if we can remember, we take A, our A in this case is negative 4, and multiply that by 1. A negative 4 times 1 is a negative 4, so that means I go down 4, so I'd be at negative 1. And then negative 4 times 4 is a negative 16, so I would go down 3 from 16, or 16 from 3, and that would be negative 13. So these would be the same. Let's check it. Let's plug in 0. 0 minus 2 is a negative 2. A negative 2 squared is 4. 4 times negative 4 is negative 16 plus 3. And we get that same exact value. It just saves some time. So we now know at 3, we're at negative 1. And at 1, we're at negative 1. And then at 0, we're down here at negative 13, approximately there. And your graphs don't have to be perfect. And so it looks like that. And that's as complicated as you can get. But let's look at what happens if we have the b value, because I think you'll have some of that on the assignment. Let's say I just did this. So our vertex, in this case, would be 2, there is no k, 0. Our transformations would be, it's multiplied by 3. So remember, it's horizontal, and it's inside, so it's the inverse, so that would be 1/3. So that would be a horizontal compression of 1/3. And then minus 2, it's inside, so it's horizontal. And it's down, it's negative 2 here, so it becomes a positive 2. And so that would be shifts to right. Now, if you have to graph these, we can't use the shortcut on this with the 3 in here. So we're going to have to go in and plug our numbers in. So 2, 0. So I'm just going to plug in 1. 3 times 1 is 3. Minus 2 is 1. 1 squared is 1. And plug in 0. Negative 2 squared is 4. Maybe we are okay. I guess you could do it that way. So this is going to be 1. So it did stay the same, even when we can go ahead and say a is 1 and it multiply by 1 and 4, and it does work, that I can go ahead and do that. So you can use the shortcut there. Next, the last thing that you're going to have to do on this assignment is they're going to ask you to use the description to write a quadratic function in vertex form. So in this case, it says the parent, so we're going to have to take this function and put it in the form of a times x minus h squared plus k. All right? So the parent function is reflected across the x-axis. Well, x-axis, if we reflect it across the x-axis, that would be vertical. So that tells me my a is going to be negative. I'm just going to write this below. I know it's negative. It's vertically stretched by a factor of 6. Vertically, again, is outside, and it's multiplied if it's stretched. It's translated 3 units left. That would be a negative 3. So the opposite of that would be plus 3. And then it is translated 5 units up. So it's outside. And that gives us our g of x function. So fairly easy on that part. So your assignment is page 320, numbers 17 to 41, the odds. And hopefully you find this, you can do it. Now again, it's real similar to the absolute value.